What is the last thing you'd expect to trip over in one of the driest places on Earth? How about the bones of possibly the largest whale to ever exist? Early estimates put it at close to 20 meters long and weighing 340 tons. And when I say big, I mean textbook example of gigantism kind of whale bone. That's exactly what happened to researchers in the Ica Desert back in 2013. And this wasn't just any big ol' whale. This species blew our understanding of gigantism completely out of the literal and figurative water, at least for a little while. This is Perucetus colossus. Hi, I'm Danielle Dufault, and you're watching Animalogic. Today we're talking about the Perucetus, a relatively newly discovered giant whale that has been confusing the heck out of paleontologists since they first laid eyes on it. So let's start from the calm before the storm. Peruvian paleontologist Mario Urbina was surveying a rock at the Ica Desert in Peru when he found these very strange fossils. Some scientists even believed that they were likely just weird rocks. The fossils were dated to be from the late Eocene, a time with few true giants, which made things even more confusing. Each of these rocks was over 100 kilograms, which meant that if they were bones, they would belong to an absolutely massive animal. But after years of working on them, chemical analyses showed that they were ancient bones. These massive boulders were vertebrae. And there was a giant buried under the rock-hard soil of the desert. It took the team 10 years to unearth all the fossils. The final haul was 13 vertebrae, 4 ribs, and a partial hip bone. The small hip bone and the club-shaped ribs resembled those of Basilosaurus, another giant whale of its time. This was a brand new species. These bones were 3.5 times heavier than the next biggest whale that had ever been found from that time period. So this was a puzzle, with pieces that wouldn't fit in any other puzzle ever solved. And the paleontologist only had 18 of the roughly 200 bones of this whale. Most importantly, they didn't have a skull, so they weren't even sure what kind of whale it was. But they did have a point of comparison, Syntheocetus peruvianus. This was another whale from the same period, and it had similar bones to Perucetus. The team used Syntheocetus as a model to see what a full-sized Perucetus could weigh, and found that the skeleton alone could be between 5.3 to 7.6 tons. That's about 3 times heavier than a blue whale's skeleton. The math also showed that Perucetus was around 20 meters in length, or about the length of 2 large school buses parked end to end. That's not quite as long as today's blue whales, so while Perucetus didn't win in the length contest, the bones implied that it might just be fighting in the wrong weight category. The team knew that modern whales have about 45 times as much flesh, fat, and organ mass than bone mass. This meant that this whale could weigh up to 340 tons, almost twice that of the blue whale, which currently still holds the title for heaviest ever animal. A big reason for this insanely huge size estimate was that they had super dense bones. They showed evidence of osteosclerosis, which means that the usually porous spaces inside were filled with solid bone. The bone was so hard, in fact, that one of the scientists studying the vertebrae said that it broke the drill on the first attempt to bore inside of it. For a brief little while, we had this vision of a sausage-shaped whale that broke all the rules of biology. Gigantic girth, extremely thick bones, and a tiny little head that somehow would consume enough food to keep up the metabolic needs of a beast this size. And this is where Perucetus gets really interesting, because the story didn't end with the headline. The first estimate made it sound like the blue whale had been dethroned, but the only thing paleontologists actually had were a handful of bones. And they were missing the skull, the tail, the limbs, and despite having vertebrae, they didn't know what the full spine looked like. All the calculations depended on how we imagined the missing parts looked like. But in biology, rules can't really ever be broken, and new teams of researchers found a few problems with the initial calculations. First of all, they pointed out that the ratio of skeleton to soft tissue doesn't stay the same as animals grow. More conservative ratios downsized the whale by over 100 tons. Other animals with super thick bones, like manatees, have a much lower ratio of soft tissue than whales. So, using their new 3D models, they calculated that it would weigh about 65 tons if it was 17 meters long, or about 100 tons if it actually grew to 20 meters. Still a giant, but not as heavy or as long as a blue whale. This might seem like just normal science squabbling, but shots were officially fired when one of the researchers went as far as saying that these estimates would make Perucetus impossibly dense. I don't know what he sounds like. If you spent any time learning about extinct animals, you'll know that paleontologists love to roast each other publicly. As we mentioned earlier, manatees and their cousins, the dugongs, have these kinds of bones. Sirenians have evolved such dense bones to counteract the natural buoyancy of all that blubber and keep them underwater close to the sea floor to feed on aquatic plants. Perucetus likely had a similar lifestyle, except it was almost surely a carnivore, because as far as we know, there hasn't been a single vegetarian whale in the whole history of cetaceans. Then in 2025, another heavy blow to the former heavyweight champion. The ancient whale that was used to find its size was argued to be wrong. Ay, Perucetus can't catch a break, eh? Instead of using Syntheocetus, researchers argued that they were closer to Pachycetus. That meant that they had fewer vertebrae, meaning that they were shorter than they originally thought, and their skeletal weight was reassessed to be about 6 tons. They also argued that calculations based on side views overestimate mass, so they also used top-down calculations to come up with their new weight estimate, about 40 tons. That's it. They wouldn't even crack the top 5 heaviest whales alive today. The blue whale, the fin whale, the bowhead whale, and the 3 species of right whale all weigh over 50 tons. So our friend the Perucetus is no longer a giant among giants. What they are, though, is the platonic ideal of being big-boned. Even at 6 tons, their skeleton is 2 to 3 times heavier than a blue whale's. So there's still a lot to marvel about this enigmatic chubster. For example, outside of arguing about their weight, what were they like? Shouldn't we be asking the important questions? Back in the Eocene, when Perucetus was bobbing around, the Ica Desert where it was found was a shallow marine environment. The buoyancy control that it would have achieved with these dense bones would have likely helped it feed in shallow coastal waters, just like a manatee. Unlike a manatee, though, Perucetus was likely carnivorous, like all other whales that we know of. But since we don't have a skull, we can only speculate about what it ate and how. Some researchers suggest that Perucetus ate bottom-dwelling animals and coastal fish, or that it scavenged on carcasses. Or it could have chased prey like giant squid and sharks, just like modern-day sperm whales, and likely Basilosaurus. But the fact of the matter is, we simply don't know, and we'll never know for sure until we find a skull. Whatever it ate, it would have had to eat a lot to maintain that huge body size, considering that a blue whale can pack away 16 tons of krill per day. That's on average about 1 million calories on the daily for the blue whale to maintain its round and perfect figure. On a general note, it's easy to understand why the expectations of Perucetus would be so high. The Peruvian desert was awash with the fossils of highly fascinating and record-setting creatures, like the freaky walrus-looking dolphin Odobenocetops peruvianus, or Inkiyaku paracasensis, a giant Eocene penguin species which was just slightly shorter than me, and Thalassocnus natans, the only known marine sloth to have ever lived. In one fossil-rich region of Peru alone, called Cerro Colorado, over 300 fossilized marine vertebrates have been found, with over 80% of them belonging to cetaceans. So Perucetus had some big shoes to fill. Even before the discovery of Perucetus, there were a couple of super famous whales found in the Peruvian desert. One extinct sperm whale, which we've already covered in detail in another video, was called Leviathan melvillei, and it was about the size of a regular sperm whale. The big difference here is that it had the largest non-tusk teeth ever discovered. Like, ever. Teeth as long as a carving knife and just as deadly. Then there was Perucetus pacificus, the 43-million-year-old whale ancestor that still had 4 limbs and webbed feet. It was dubbed the walking whale, and it was capable of leading a double life on land and in the water. It definitely didn't look like a whale, but more like a beaver or an otter. Whales are incredible examples of evolution that we can see with every newly discovered specimen. But that's why Perucetus, while not setting any records other than heaviest mammalian skeleton, is so important. Its discovery proves to us that whales started evolving into the giants we know today a lot longer ago than we initially thought. Until unearthing Perucetus, we believed that whales started evolving into their gigantic selves within the last 5 to 7 million years. And here is Perucetus, 39 million years ago, blowing that out of the water and making us question everything we thought we knew about whale evolution. It also gave us a new type of whale, one built like a tank, shaped like a manatee, and with the face of an ancient whale back when their heads resembled land predators a bit more. TBD on when we find a skull, though. What other fossil giants are there sleeping under rocks, just waiting for a keen eye to notice that their bones are more than just rocks? In the case of Perucetus, until we have a full skeleton, we may never have a complete understanding of the implications of this massive species on whale evolution as a whole. All the more reason to keep exploring the bountiful Peruvian deserts for the next big discovery.
Just off the coast of Guam, the ocean floor splits open into the deepest scar on Earth, the Mariana Trench. From the surface, it looks like your classic tropical blue water. Sunlight, reefs, turtles, sharks, dolphins. But below them, there are multiple different worlds. The 11-kilometer descent into the pressurized, cold darkness creates creatures so strange, they feel like they evolved on another planet. So today, we're going on a vertical safari from the sunlit surface to the deepest point on Earth, layer by layer, to see how life changes when animals adapt to life at the deepest point of the ocean. This is the wildlife of the Mariana Trench.
What happens if you remove any sunlight, add crushing pressure, and just keep going for 11 kilometers? It's a place on Earth that humans have visited less times than we've walked on the moon. It's the deep ocean.
Just off the coast of Guam in the Western Pacific lies the deepest place on Earth, the Mariana Trench. A place so deep that if you dropped Mount Everest into it, the summit would still be more than a kilometer underwater.
That's a little unnecessary. The ocean's deep enough, we can, protect Mount Everest's ego a little bit.
But as you dive in, the ocean doesn't just get deeper, it gets weirder. Layer by layer, the rules of life start to change. We're talking animals with transparent heads, detachable jaws, and teeth too big for their bodies.
So today we're sinking from the surface to see what goes on at Earth's deepest point.
At the surface above Mariana's Trench, things feel familiar. We're basking in the sunlight zone. It goes down for roughly 200 meters. As the name would suggest, sunlight floods the water, allowing for photosynthesis to occur. This zone hosts most marine life, including dolphins, sharks, and algae. We're near Guam in the Western Pacific. To the west, the Philippines. To the east, nothing but thousands of kilometers of open ocean all the way to Hawaii. Coral reefs like these, built on ancient volcanic rock, bustle with crowded ecosystems where thousands of species compete for food and territory. The first animal we encounter on our Mariana safari is the green sea turtle, drifting calmly along, unbothered by the 11 kilometers of inconceivable depths below. Nearby, black-tip reef sharks slice through schools of fish. And near the coast of Guam, spinner dolphins launch themselves into the air like spinning torpedoes, while a hungry orca watches from below. A massive ocean sunfish, basically the pancake of the sea, floats near the surface while seabirds pick parasites off its skin. And not too far from there, a whale shark cruises with its mouth wide open, filtering thousands of liters of water for plankton. And trailing through it all, the lion's mane jellyfish drifts like a living minefield. Its tentacles are longer than a school bus and armed with stinging cells. Light powers everything here. Photosynthetic plankton form the base of the food web. They use sunlight to turn carbon dioxide into chemical energy, supporting almost every other organism in the upper ocean. But once you leave that light behind, you lose your main energy source. And from that point on, survival gets creative. At 200 meters below the surface, only about 1% of sunlight remains. Enough for a dim blue glow, but not enough for plants to survive. This is the twilight zone, and it's the point where color starts to disappear. The first one to go is red. This is why so many animals here are actually bright red, like dragonfish and deep-sea shrimp. Red light has the longest wavelengths and is absorbed before it can reach these depths. So down here, red looks black. It's camouflage. Some animals take that invisibility even further. The stoplight loosejaw is nearly invisible, but it can produce red bioluminescence, a flashlight that only it can see. Most deep-sea organisms can only see blue or green light, so this red light allows the loosejaw to illuminate prey, such as crustaceans, without warning them or attracting larger predators. Deep-sea dragonfish do this too. They have red light searchlights from organs behind its eyes, like the coolest pair of night fishing goggles no one else can see.
Twilight taxa are just built different, you know?
Bioluminescence is everywhere here. Lanternfish glow along their bellies to erase their silhouette, a technique called counter-illumination.
They're basically deleting their own shadow. It's a power move.
Female anglerfish dangle glowing lures like fishing rods. This is a modified dorsal fin spine that extends over her mouth. At the tip is a fleshy growth filled with millions of bioluminescent bacteria that glow in the dark. Viperfish wave a long dorsal fin ray with a light organ on its tip. And dragonfish have a barbell under their chin that does the same thing. The technique is all the same. Attract curious animals close enough to become an easy meal. The deep-sea version of, come look at this shiny, sparkly thingamabob I have for you. Look at that. Isn't that nice?
If a crustacean follows the light, it dies.
In a classic Uno reverse, animals like the vampire squid use bioluminescence to escape. Despite its name, it is neither a squid nor a true octopus. When threatened, it doesn't shoot ink. Instead, it flips its webbed arms inside out, revealing fleshy, finger-like projections called cirri, and releases a cloud of glowing, sticky mucus. This confuses predators and makes the predators themselves visible to larger predators.
This is the deep sea equivalent of saying, look over there, and then throwing a glitter bomb into the deep abyss. I would also like to take a moment to appreciate the fact that the vampire squid lives in the twilight zone.
Some of the strangest creatures here aren't even single animals. Siphonophores are colonies of clones, each part specialized but working as one. Each unit is genetically identical but performs a completely different job, like feeding, reproducing, or hunting. Together, they form glowing chains that can stretch longer than a blue whale. You can get the full down low on these superorganisms here But the real backbone of this ecosystem aren't the flashing lights, creepy clones, and toothy predators. They're tiny drifting organisms called zooplankton, especially copepods. There are so many of these small crustaceans that they may be the most abundant animals on Earth. Tens of thousands of them can be found in just a single bucket of seawater. As popping as the Twilight Zone seems, every night, billions of creatures have to rise towards the surface to feed. This vertical migration from the Twilight Zone is the largest movement of biomass on Earth.
This daily movement is pretty important for the ocean's ecosystem. It acts like a big carbon pump, pumping carbon from the atmosphere down into the deep ocean, mitigating climate change.
The Twilight Zone is just a sliver of the expanse below. As we sink down 1,000 meters, sunlight effectively disappears. The influence of the surface fades, and the ocean becomes cold, dark, and amazingly stable. This is the Midnight Zone. And, unless you have an inbuilt flashlight, the ocean becomes permanently dark from this point on.
I mean, not that you'd notice, because if you'd made it this far without a pressurized vessel, all of your air-filled cavities, like your lungs and your sinuses, would violently collapse. You'd implode.
Down here, food is scarce, and encounters are rare. Not a single ray of light makes it this far. The water sits just above freezing, so animals are built for efficiency or patience. In areas of the valley with seafloor in the Midnight Zone, the tripod fish stands on long, spindly fins like stilts facing into the current. It barely moves, waiting patiently for food to drift straight into its grasp. A pelican gulper eel drifts through the dark with a mouth large enough to swallow prey bigger than itself, which is a gamble on a meal that might come once in a lifetime. Side note, no human being has witnessed eels mating or have directly found their eggs in the wild. So we know what they eat, how they hunt, where they live, but how they get it on? A mystery as eerie as the Twilight Zone. Deep-sea anglerfish down here rely almost entirely on their glowing lure to hunt. Their bodies are soft, energy efficient, built to survive long stretches without food.
And dating down here, like anywhere, is complicated.
Male anglerfish are tiny and parasitic. Encounters with mates are extremely unlikely, so when they find a female, they latch on. Permanently. Their bodies fuse. The males lose most of their organs. Eventually, they become little more than a source of sperm.
Now, I would suggest finding someone to talk to about this unhealthy codependency, but I imagine that in the deep sea, it's probably harder to find a therapist than a girlfriend.
Not everything hunts here. Here, the vampire squid extends its long filaments into the water and waits for marine snow, which are tiny flakes of dead plankton, fecal matter, and organic debris drifting down from above.
To be a floating piece of ocean dandruff. Not a care in the world. All other animals can do is look up, literally.
In the Midnight Zone, some fish evolve tubular, upward-facing eyes, tuned to detect the faintest silhouettes breaking the darkness above them. They're not looking for light itself, but the contrast, the dark shape of prey or predators moving against the barely brighter water coming from higher up. Just like the barrel eye fish, whose upward-aimed eyes are embedded inside a transparent head. This lets them effectively scan overhead while protecting their vision from flashes of bioluminescence.
That's called looking on the bright side.
Up in the Twilight Zone, the Pacific hatchetfish survived by using bioluminescence to match the light from above and erase its outline. But in the Midnight Zone, that strategy starts to fall apart. And sometimes, crushing pressure can be the best beauty routine. The blobfish has a reputation for looking like a melted face, but that's only at the surface. Down here, it looks like a normal fish. It's only when we bring it up that its body collapses into that infamous blob. Now we've dove 4 kilometers under the surface in an eerie realm called the Abyss. Here, a vast, cold sea floor stretches across a desert of silty plains. Temperatures hover near freezing. Pressure is immense, like 50 jumbo jets pressing down on your body immense. The few animals here are mud dwellers. Food arrives slowly in the form of whatever sinks.
So that means that everything down here lives on leftovers. It's not an easy life, but hey, life finds a way.
Sea cucumbers, also called sea pigs, dominate the seafloor. They crawl along using tube feet, vacuuming up sediment and extracting whatever nutrients they can.
That's a smart way of saying they eat dirt.
Glass sponges build their skeletons from silica, so basically glass. They form intricate, fragile structures that look like they belong in a museum. Some can live for thousands of years, quietly filtering water in the dark. Acorn worms leave winding trails across the seafloor. They use gill-like structures that filter nutrients right out of the mud. They can grow up to 2.5 meters long and can regenerate significant parts of their bodies when injured. You might see a Dubeau octopus slowly drift past using its ear-like fins to hover. They have evolved a slow-mo lifestyle to survive this extreme pressure and darkness, securing its title as the deepest living octopus known to science. You might also see a feather star drifting through the darkness and spreading its delicate, branching arms like a living net, catching particles as they fall. It looks like a plant, but it can crawl across the seafloor when it needs to.
So, under 6,000 meters, we enter the Hadal Zone, named after the Greek mythology underworld. And for good reason.
The seafloor here drops into massive trenches formed at subduction zones, where one tectonic plate slides beneath another. It's a dynamic, shifting landscape where the Earth is constantly in motion. Earthquakes are frequent in and around the trench. This is the deepest, most extreme environment on Earth. Pressure here can be 1,000 times what we feel at the surface. You'll meet the deepest living fish on Earth here, the Mariana snailfish. Soft, gelatinous, cartilage instead of bone, not built to resist pressure, but to exist within it. Its cells are packed with molecules like TMAO, which stabilize proteins under extreme pressure and prevent the cells from being crushed. They are top predators in the Hadal Zone, possibly even the absolute lowest point of the ocean, known as the Challenger Deep.
At this pressure, even biology starts to break down. Proteins lose their shape and cell membranes destabilize. Life doesn't just have to adapt physically, it has to adapt chemically.
You would think there would be a limit to how deep fish can go, but beyond a certain point, pressure interferes with the chemistry needed for complex life. That's why the lowest parts are inhabited by mostly microbes and simple invertebrates. And plastic bags. Even at nearly 11,000 meters down in the Challenger Deep, a place once thought untouched by human influence, plastic bags have been found resting on the seafloor.
These conditions support chemosynthetic bacteria that don't rely on sunlight. Instead, they use chemicals like hydrogen sulfide or methane to produce energy.
Hierondelia gigas, tiny amphipods, scavenge the seafloor. They reinforce their bodies with aluminum extracted from sediment, helping prevent their shells from dissolving under pressure. While more rare than above, sea cucumbers and Dubeau octopuses still drift across the sediment. Overall diversity and density of life drops as we descend into these narrow trenches. You can also see giant amphipods like Alicella gigantea roaming the trench, sometimes growing larger than their shallow water relatives. This is a phenomenon called deep sea gigantism, the tendency for deep sea species to grow significantly larger than their shallow water relatives. Metabolism slows down, lifespans stretch out, and these creatures have all the time in the world to grow into giants. We'll still see xenophyophores on the seafloor of the Mariana Trench. These are giant single-celled organisms. So, just one cell, but many nuclei. They're not animals, plants, or fungi, but are a type of amoeba that can grow up to 20 centimeters or more in diameter. Within this vast, shifting Mariana Trench, the seafloor drops even further into a final, hidden scar, the Challenger Deep.
A valley within a valley, the absolute deepest point on planet Earth.
Against all odds, At nearly 11,000 meters below the surface, a sparse but specialized ecosystem still persists. Amphipods, hadal sea cucumbers, sediment-dwelling worms, and pressure-adapted microbes on the sea floor. A lot is still to be discovered about this hidden world. For a long time, we thought nothing could live at these depths. That changed in 1960 when the bathyscaphe Trieste descended into the Mariana Trench. During the dive, an outer plexiglass layer cracked under pressure. They were pushing the limits of what was physically possible.
But when they reached the bottom, it wasn't empty. They saw movement. Small, shrimp-like creatures moving along the sediment. That's proof that even here, in the most extreme conditions on Earth, life persists.
To explore this abyss isn't just to satisfy our curiosity, it's to better understand the fragility and the sheer tenacity of life on Earth. Today, we traveled from sunlit reefs to the deepest trench of the Earth. We saw how weird things can get from just changes in light, pressure, and energy.
And yet, there is still so much more to explore, and surely tons of amazing things to discover.
The largest toothed whale in the world is a giant slayer, and it hunts in perfect darkness. From the freezing cold of the Norwegian Sea to the tropical waters of the Caribbean, clans of deep-diving, squid-hunting, chit-chatting, big-brain mammals patrol the ocean's depths. A 2-kilometer, 60-minute drive into freezing darkness to fight and eat giant squids is just a regular Tuesday for a sperm whale. This is the sperm whale. Sperm whales have one of the toughest jobs in the animal kingdom. They have to dive into the ocean's midnight zone and get in a wrestling match with the largest invertebrates in the world, giant and colossal squids. They eat so many squids that most of the evidence we have of the existence of giant squids comes from the inside of the bellies of these mammalian beasts. But it takes a lot more than just being a good swimmer and a strong biter to nab these squids. To do this, sperm whales have to be marvels of engineering. The first issue they have to deal with is getting into the midnight zone, where giant squid squads live. Fat floats, and whales are, to put it respectfully, a bit on the heavy side. Nothing wrong with that. To get up to 3,000 meters below the surface, sperm whales draw cold seawater into its nasal passages. This cools down a white, waxy substance in the head called spermaceti and turns it into solid wax. The solid wax is much more dense than in liquid form, and it makes the sperm whale sink. Think of this process like an evolutionary ballast. Instead of sperm whales wasting energy swimming downwards, they can activate diver mode and free fall with minimal effort. Preserving energy and oxygen is key when hunting over 1/2 ton of food a day. The global population of sperm whales catch about 100 million tons of seafood per year. That's a little more than all the wild catch of the world's commercial fisheries combined. Holy mackerel, that's a lot of seafood. But getting down there is easy. Even I could do it. The hard part is surviving. Whales withstand the immense pressure thanks to their collapsible lungs and flexible ribs. Their lungs basically become deflated balloons, which stops them from absorbing nitrogen in the air stored in the lungs. And instead of relying on air to get their oxygen, they store it in their blood and muscles. Their body switches to low power mode, letting them stay underwater for an entire episode of Euphoria. Just think about it. All the drama above and below the sea. Okay. You've made it into the depths of marine hell. Now, how would you go about finding a giant squid? We have a lot of trouble with that, and have only spotted a handful of them alive at these depths. But sperm whales have a power we don't have. The power of friendship and echolocation. Sperm whales can navigate complete darkness by using its head as a sonar. They emit loud clicks and listen to the echoes to create a mental 3D map of the dark. These far-reaching clicks, which are some of the loudest animal-made sounds on Earth, are used to map out the location of their prey in an intense game of pitch-black hide-and-seek. And sometimes, the mental map echolocation creates has a giant X that says, "Here be monstrous meals." Then, it's time to engage in hunt mode. What happens next? We only know based on indirect evidence. Squid versus whale. A battle which has never been seen and remains a mystery. It combines Lovecraftian horror, thalassophobia, and megalophobia. Hopefully one day we'll be able to see it, But for now, all we have as evidence are its after effects. Whales carry their battle scars on their skin and the indigestible body parts of their foes in their stomachs. Those wounds are the whale definition of street cred. You see these giant beaks? They were all found in the belly of a whale. But getting those beaks in those bellies is a whole other issue. Thankfully, sperm whales come equipped with premium squid-catching gear. The sperm whale only has bottom teeth, which slide and lock perfectly into place in their toothless, fleshy upper jaw. This allows them to suction and then swallow their delicious entrees whole. Besides giant squids, cods, deep-sea sharks, and even some larger anglerfish are often found in sperm whale bellies. A big part of their success hunting giants in the dark and thriving in these light-forsaken places is their ginormous head. A sperm whale's head makes up 1/3 of its total body length, with mature males reaching over 15 meters. So if we do the math, this means sperm whales have heads that are 5 meters long. That's enough room to house the largest brain in the animal kingdom. 8 kilograms of goopy goodness, or about 5 times as heavy as your brain. One of their big brain moves is being able to live in societies. But we'll get back to this in a little bit. For now, let's focus on the adaptation that gave them their name, the fluid in their heads, the spermaceti. In the 1700s, whalers caught and cut open sperm whale heads, and in each one of them found up to 3,000 liters of a light, yellowish fluid that reminded sailors of a reproductive fluid. Hence, the name sperm whale and the term spermaceti. But the seamen were wrong. As you can imagine from the fact that it's in their head, spermaceti is not for reproduction, but an evolutionary jack of all trades, aiding in everything from buoyancy control, diving, echolocation, and combat. Under normal temperatures, spermaceti is liquid and creates a positive buoyancy. That means that a 45-ton male can float effortlessly. That also means that their head is more buoyant than their bodies, which is why when they sleep, they look ominously vertical, suspended in the water column. This vertical drift position lasts only 10 to 15 minutes and usually occurs just below the ocean surface. This upright sleeping position allows sperm whales to stay close to one another and maintain social contact while resting. It also makes surfacing to breed easy because of the positioning of their heads. Sperm whales are among the least sleep-dependent mammals on Earth, spending about 7% of their lives asleep. For comparison, the average human spends roughly 1/3 of their life sleeping, and that's with coffee. When two sperm whales fight, they ram each other. Giant noggin to giant noggin. The spermaceti protects their brain from damage by giving it a thick, waxy cushion. This would be an important job for any animal, but for the sperm, it's crucial because their brains are truly special. It has a complex neocortex system with an abundance of spindle neurons. In humans, these same neurological structures are related to social networks, speech, and empathy. All of these behaviors have been observed in sperm whales in their clan interactions and when defending themselves from predators. It's hard to believe that the world's largest predator has predators, right? Like, who is silly enough, or should I say, smart enough, to fight a sperm whale? The answer is the brainiac of the ocean, the killer whale, or orca. Pods of orcas are smart to avoid mature bull sperm whales that are up to 6 times heavier and 3 times longer than the average killer whale. That's why they usually go for females or babies. The difference in size between male and female sperm whales is one of the most extreme examples of sexual dimorphism in the animal kingdom. Just look at the difference. A female will only reach a maximum of 13 meters, while a male will grow up to 20 meters and weigh up to 3 times more. When orcas attack a clan, sperm whales use a defensive position called the Marguerite formation. The stronger members of the clan circle around the most vulnerable, with their tails facing outward and heads pointed towards the center. If the orcas attack, the sperm whales use their tails and heads to fend them off. But sometimes, orcas succeed, and they take young or sick sperm whales, making them the sperm whale's greatest natural threats. Defense is only one of the sperm whale's group activities. These groups, which can sometimes be up to 70 whales strong, are communities in which whales seem to dance and play together, doing all sorts of dips and twirls. And on a more practical level, they hunt and take care of babies communally. New mothers even take turns nursing each other's calves. It just makes good sense to split responsibilities with the other ladies. Who else is going to feed and watch the baby while mom's off hunting giant squid? Especially when calves nurse for up to 5 years. Ugh. The life of a single mom. These complicated social structures are organized the same way as humans. No, not by social media, but through language. Remember those loud clicks that sperm whales use for echolocation? Well, those acoustic vocalizations are also used to communicate with one another in intentional sound patterns called codas. Codas differ from clan to clan, which means that communication is a learned behavior. Baby sperm whales aren't born knowing how to communicate, but instead, they babble and mimic sounds until they too know how to communicate with their home group. That's exactly how human babies learn to speak. Unfortunately, some of the first things they might learn to say is, "Stay away from humans." The human attacks on sperm whales go back to the 17th century, when their spermaceti was prized for making high-quality candles, lubricating machinery, and even producing cosmetics. Although spermaceti candles burned cleaner, brighter, and longer than the common beef tallow candle, it was way more expensive and reserved for only the wealthy. Think of it like a Gwyneth Paltrow goop candle of its time. This candle smells like my spermaceti. To defend themselves from whalers, sperm whales were reported to use their giant heads as battering rams, striking and in some cases sinking whaling ships. Moby Dick was inspired by the sinking of a whaling ship, the Essex, by a sperm whale in 1920. But despite their intelligence and power, sperm whales spent centuries in a losing battle with humans. More than 200 years of commercial whaling wiped out half of their global population. But thanks in part to the Greenpeace Save the Whales campaign and a global ban on commercial whaling in the 1980s, today's sperm whale numbers are no longer considered endangered. That doesn't mean we're no longer their biggest threat. Human activities like commercial fishing and shipping are a huge problem for them. Sperm whales rest near the surface, making them extremely vulnerable to fatal ship strikes. Efforts by the Caribbean nation of Dominica are leading the way in sperm whale conservation by creating a 700 square kilometer ocean reserve where no commercial vessels or fishing are allowed. Sperm whales' iron-rich poop create plankton blooms that are extremely effective at capturing carbon dioxide. They also like to poop in unison when socializing. A population of 250 sperm whales can help stimulate enough plankton growth to capture the carbon of roughly 18,000 acres of forest. In the words of Herman Melville, the author of Moby Dick, "There is a majesty in the sperm whale which no other fish possesses." And man, was he both right and wrong. Of course, they're not fish, but they are majestic as fluke. Here's to the best whale with the worst name. It's not good. Every era has a champion. There's always a bigger fish, except when you get to the biggest, meanest, and hungriest of them. But eventually, all the great champions fall. From the earliest giant monsters to the current heavyweight champions, we're going to show you who has been the king of the oceans. And we're going to tell you why they got so big, how they got their massive meals, and why they lost their title to the next great super predator. These are the ocean's heavyweight champions. The time of ocean monsters started a little over 5 million years ago. Long before dinosaurs, whales, or even forests, the Earth was a barren, rocky, plantless landscape. It had no polar ice and higher sea levels. The real action was underwater. For billions of years, tiny photosynthetic organisms had flooded the seas with oxygen, unlocking the potential for larger bodies, active predators, and more complex creatures. This was the Cambrian period, home to the legendary Cambrian explosion. The Cambrian explosion was an intense, rapid burst of marine evolution. Suddenly, strange new creatures and adaptations appeared everywhere. Even eyes were a brand new invention. The oceans filled up with weirdos and alien-looking creatures, and above them all swam one of the first true apex predators on Earth, and our first heavyweight champion, Animalocaris. The name means abnormal shrimp, and it lived up to its name. It had huge, spiky arms to hook and grab prey. Its eyes had thousands of lenses, and its circular mouth was lined with jagged plates. It was a biblically accurate prawn. Anomalocaris was around 0.5 meter to 1 meter long, which might not sound terrifying by modern standards, but at the time, this thing was a giant among minnows.
To Cambrian animals, this was an alien gunship. Soft boys like worms, early jellies, and soft-shelled arthropods lived in fear of being spotted by any of its thousands of lenses. Nothing dared hunt Anomalocaris. But if something did, by my calculations, it probably would have tasted something like a mix of shrimp, lobster, and cockroach.
This guy was so weird that scientists doubted at first if its parts belonged to a single animal. Its spiked arms were thought to be that of a shrimp-like creature. Its circular mouth was mistaken for that of a fossilized jellyfish, and its main body was classified as a sea cucumber.
It was sort of a Cambrian platypus, and even though it would have been immediately pulverized by later champions, it can always claim to have been the first. For the first time, evolution had crafted an active hunter built for speed, sharp vision, and active pursuit. It's the start of an animal kingdom as we know it, and it changed everything. Scientists think predators like Anomalocaris may have triggered an evolutionary arms race during the Cambrian explosion. Survival of the fittest, baby.
Before apex predators like Anomalocaris, many animals lived a chill, exposed life on the seafloor. But when the killers got fast and good at finding prey, the rest had to scramble to keep up. Suddenly, armor, speed, camouflage, and hiding mattered.
Unfortunately for our wide-eyed friend, by the end of the Cambrian period, around 485 million years ago, the oceans were becoming unstable. Sea levels shifted, oxygen levels dropped, and entire marine ecosystems collapsed. This was one of Earth's earliest mass extinctions. Huge numbers of the bizarre creatures that dominated Cambrian seas simply vanished. One of them was Anomalocaris, who had ruled the seas from the Cambrian explosion to the Cambrian implosion. But extinction is as much a creator as it is a destroyer.
The next geological era was the Ordovician. It took just a few million years for the seas to be busy again. Early fish, trilobites, and primitive reef ecosystems flourished. The heavyweight champion title was vacant. Straight-shelled cephalopods like Protocameroceras were already beginning to push size and shell length, evolving more efficient buoyancy control and a more active predatory lifestyle.
This was a winning strategy that helped them catch prey both at the sea bottom and in the water column. And it didn't take long for a new heavyweight champion to perfect that form. This was Cameroceras.
Picture a 2-meter squid sealed inside of a giant cone-shaped shell, a world away from the meter-long shrimp-like Anomalocaris who had ruled the oceans not long before. It lived in shallow tropical waters, it was fast, and used jet propulsion to move its massive bulk and ambush its prey. Its shell was divided into a series of gas-filled chambers that the creature could flood or empty, allowing it to control its depth like a biological submarine. It also had beaks that could crack the exoskeletons of sea scorpions, trilobites, and other ocean tough cookies.
I'm kind of in awe at how fast evolution arrived at giant, terrifying cephalopod. Earth had barely finished building its first reefs, and there was already something with both tentacles and a beak lurking in the shadows. About 20 million years after Cameroceras got its belt, another extinction event sent this champion to retirement.
Around 445 million years ago, the first of the big 5 mass global extinction events took place. This was the late Ordovician mass extinction. The planet got cold, and many of the shallow water habitats where Cameroceras' food lived and reproduced froze.
This ice age eventually wiped out much of their prey, and soon after, Cameroceras followed them into species heaven. By today's standards, these early predators ruled a world that was still surprisingly simple. Most species were invertebrates, but after the Ordovician, some vertebrates grew a spine and a jaw and challenged their noodly overlords. About 85% of marine species died during this extinction event. But when the dust settled, fish took over. Around 400 million years ago, Earth's oceans entered the age of fishes.
The Earth got warm again, and high sea levels flooded the continents, creating vast, warm, shallow water habitats. Intense tectonic activity and new ocean crust increased calcium and magnesium levels in the water. Reefs love these conditions and quickly spread across the shallow seas. These reefs were massive and sprawling mounds of stone skeletons made of corals, sponges, and algae that glued everything together like cement.
Armored fish thrived in the nooks and crannies of these stony labyrinths and quickly diversified. Their armor protected them from each other and also from the early sharks, slender, restless hunters gliding through the shadows in search of prey. But they were still minnows compared to the third heavyweight champion in our story. Around 380 million years ago, sharks got dunked on by Dunklestyus.
The dunk was a massive placoderm fish that could reach around 4 to 6 meters long and weigh about as much as a modern hippo. Instead of teeth, it had bony plates along its jaws. These blades would rub together every time it clamped its mouth shut, making them permanently self-sharpening and ready to slice through bone and armor in an instant. Unlike earlier champions that picked on the soft and squishy, Dunklestyus leveled up and went after armored prey. As an ambush hunter, its jaws snapped open and shut so powerfully that they likely could have pulled prey into its mouth.
The dunk seemed unbeatable for a while, but eventually, the only real undefeated force on Earth, climate change, took them out. Yep, another mass extinction event.
This was the late Devonian mass extinction, a series of disasters that happened around 360 million years ago. It was a perfect storm. The climate shifted, reefs fell apart, and volcanic activity increased. Forests spread, building new nutrient-rich soils for the first time. But this triggered massive blooms of algae and cyanobacteria, which sucked the oxygen from the seas.
That spelled the end for Dunklestyus and all other placoderms. Heavily armored reef hunters were replaced by faster, lighter predators that could survive in more unstable open water. Cartilaginous fish were one of the surviving lineages that wouldn't take long until they produced the strangest heavyweight champion in history.
Yep, this thing existed. Its name was Helicoprion and lived around 270 million years ago during the Permian period. It was an open water pursuit hunter about the size of an orca.
But let's stop beating around the bush. What makes this fish a world champion is its puzzling buzzsaw teeth. If you saw Helicoprion alive today, you'd swear it was a creature from a fever dream. Seriously, if you're multitasking, look up from your phone, take a look at this thing.
For decades, scientists had no idea where this tooth whorl even fit on the animal. Some thought it stuck out from the nose, but modern scans revealed the truth. The spiral was tucked inside its lower jaw. As old teeth grew, new ones rotated forward like a conveyor belt of blades. It specialized in slicing up slippery, soft-bodied prey like squid, slippery fish, and ammonoids. It was the first champ that would have totally lost a fight against a previous champ. Its teeth didn't have to crush armored fish because they were gone. So the dunk would have eaten it for breakfast.
The good news was, in its world, a lot of prey was soft. The bad news is that it lived during one of the worst times to be alive, possibly ever. During its reign, the Earth was headed towards the single worst mass extinction in its history, the Great Dying.
Volcanic eruptions triggered catastrophic climate change. Oceans, yet again, lost oxygen, and temperatures skyrocketed. This came to a violent end, and roughly 90% of marine species vanished.
The age of fishes nosedived. Nosedove? It ended. But if there's anything we've learned, extinction always leaves a vacuum, and there's always contenders waiting for their chance at the throne. The next champions wouldn't be fish or other oceanic royalty, but animals that evolved on land and took over the sea when they saw an opportunity. This was the beginning of the Age of Reptiles.
The year was 245 million BC. Nearly all land was fused into the supercontinent Pangaea and was surrounded by the vast global ocean Panthalassa and warm, shallow coastal seas. The oceans had barely recovered from total collapse, yet giant predators were already rapidly evolving to dominate the recovering world. Ichthyosaurs were some of the early contenders, being early reptilian adopters to the marine lifestyle, but the first reptilian heavyweight champion was Thalattoarchon. Its name literally means ruler of the seas. At around 8 meters long, this beast had giant bladed teeth and enormous jaws designed for hunting and slicing through the flesh of other marine reptiles.
Thalattoarchon appeared only a few million years after the Great Dying, but the reptiles were just getting started. Soon, some ichthyosaurs would grow to sizes rivaling modern whales, and the reign of Thalattoarchon would be gone in the blink of an eye.
Meet our new champion, Shawnosaurus. They evolved from small land-dwelling diapsid reptiles that moved into the warm, empty sea after the Great Dying. Shawnosaurus and other giant ichthyosaurs may have grown over 20 meters long, bigger than a school bus. Their fossils were so large that Nevada miners once used their vertebrae as dinner plates. Today, Shawnosaurus is Nevada's state fossil, a reminder that the desert was once an ocean ruled by reptilian giants.
Scientists once thought that this reptile was a gentle, toothless filter feeder, but recent fossil evidence reveals that they have large, sharp teeth and dined on fish, squid, and mollusks. They were probably aggressive hunters that excelled in deep waters. As prey animals started living deeper, Shawnosaurus made these depths their hell.
Most speedy marine creatures use disproportionately larger front flippers to keep them from nosediving when propelling themselves with their tails. But Shawnosaurus was still an early transitional ichthyosaur, so it retained 4 equally sized paddle-like limbs that it inherited from its terrestrial ancestors. This likely gave it excellent vertical control to hunt in deeper waters. It also had a deeper, bulkier body, resembling an oversized ocean sunfish or a modern whale, unlike the slender, dolphin-like silhouettes of many later ichthyosaurs. This, along with its excellent vision, also allowed them to thrive in the ocean's depths.
But as more top reptiles of this era were returning to the sea and prey became larger and more mobile, later giant ichthyosaurs evolved more streamlined bodies for speed and efficiency rather than brute force.
Later ichthyosaurs weren't fish or dolphins, even though they looked the part. They just convergently evolved to look weirdly similar, because fast swimming in open water tends to push animals towards the same sleek shape.
Nature just keeps reinventing the torpedo. Oh, can you hear that? Are you hearing voices telling you that another mass extinction was on its way to take out these speedy reptiles? Yep, this time the voices are right. 200-ish million years ago, the Triassic ended with another mass extinction, just like it began.
As Pangaea began slowly tearing itself apart, enormous volcanic eruptions poured lava across huge swaths of the planet. Tons of greenhouse gases were pumped into the atmosphere, and Earth got as hot as 2 rats wrestling in a wool sock, as my grandma used to say. The oceans became warmer and more acidic, and ecosystems began to decline. Giant marine reptiles weren't too happy about this. Over 80% of marine species and 70% of terrestrial life disappeared forever. But some lineages survived, and one of them gave us our next heavyweight champion. Meet Plesiosaurus funki, better known as Predator X. They were short-necked marine reptiles about 12 meters long with a skull of nearly 2 meters long. Predator X ambushed giant fish, sharks, and other marine reptiles like plesiosaurs.
Some people think that the mythical Loch Ness monster is inspired by the plesiosaur, and if anything would have hunted Nessie, it would have been Predator X. Basically, the oceans were now filled with giant reptiles being hunted by gianter reptiles.
With banana-sized teeth and an incredible bite force, Predator X looked like a fighter jet and may have been stronger than any modern predator. To put it in perspective, its bite was as powerful as having an adult elephant sit on your chest, and an estimated 3 times stronger than today's saltwater crocodile, the most powerful bite alive today. As if that wasn't enough, They had a few other tricks up their fins. They had specialized sensory pits on their snouts to help track prey, and a third parietal eye on the top of their skulls to help them navigate by sunlight in murky water.
The Jurassic and the early Cretaceous oceans were horrifying. Reptiles kept getting bigger on land and in water and in the sky. And by around 130 million years ago, pliosaurs were usurped of their throne by mosasaurs, which gave us two massive co-champions.
Mosasaurus and Tylosaurus were enormous marine lizards related to Komodo dragons. They stretched sometimes over 14 meters long. They rose quickly in evolutionary terms, less than 20 million years from land-dwelling lizard ancestors to fully ocean-adapted hunters. Dinosaurs, by comparison, had already ruled the Earth for over 160 million years, slowly branching into hundreds of forms across land and sea.
The pliosaurs of the past ruled as ambush hunters, with brute force and explosive attacks. But the mosasaurs took a different approach. Open water had expanded, and prey spread out. Strength and speed became necessary skills to kill.
Built with long, powerful bodies, shark-like tails, and flexible skulls, they moved through open water as fast, highly efficient pursuit predators. They were so committed to the seas that they even gave birth to live young, never returning to land to lay eggs. They hunted fish, seabirds, ammonites, turtles, sharks, and even other mosasaurs. Just like modern snakes, Mosasaurus's jaws could unhinge to swallow massive prey whole. Fun fact, and buyer beware, fake Mosasaurus jaws are one of the most widely available fossil forgeries.
Fossil theft aside, the scariest part to me is how modern mosasaurs seem. Earlier predators feel alien, but Mosasaurus? You can almost imagine one surfacing behind your boat. They look basically just like whale sharks with a Komodo dragon's head. For tens of millions of years, they dominated the late Cretaceous oceans. Then, an asteroid changed everything. Yes, that asteroid.
66 million years ago, the Chicxulub asteroid's massive impact triggered wildfires, tsunamis, and a darkness that lasted for years. The ocean was no place for massive reptilian hunters. Mosasaurus disappeared alongside the dinosaurs, and the age of reptiles ended. But once again, empty oceans created opportunity. And this time, it was our turn to move in. All large land reptiles died out, but in the ashes, small mammals were better able to survive the devastated world. Many could burrow underground, eat almost anything, and survive on limited resources during the global collapse. Yes, our mammalian ancestors were short king survivors.
As ecosystems healed, mammals quickly diversified to fill the gaps left by dinosaurs. Some took to hunting in rivers and the warm, shallow coastal seas that stretched nearly pole to pole. Over millions of years, these shoreline prowlers transformed into fully aquatic whales, the next rulers of the ocean. Soon after, we got our first mammalian world champ. This was the terrifying Basilosaurus.
It lived about 40 million years ago and could grow nearly 18 meters long. Their skeletons were so long and slender, they almost look like snakes. Basilosaurus's eel-like body cruised ancient warm seas, hunting bony fish, sharks, and smaller whales. It still carried tiny, useless hind limbs, a leftover from its land-dwelling past.
Aww, it was like a little underwater T-Rex. Except it wasn't little, it was like really big. Whale evolution sounds fake, but it isn't. Their ancestors walked on land, but over time, more and more of them spent time in the shallows until their descendants became ocean giants. Now, we'd like to claim the title for most creative evolutionary path, but reptiles had already done that before, and also some had turned into birds, so we have to give it to them.
But whales kept evolving. Some specialized in filter feeding and became the largest animals in Earth's history, and others became even greater hunters. But sharks didn't just roll over and let mammals take over the oceans. Around 12 million years ago, the Earth's oceans had two colossal co-champions, Megalodon and Leviathan. Megalodon may have reached 15 to 20 meters long. This gigantic shark butchered whales with its serrated teeth bigger than your hand. On the mammal side, Leviathan, a giant predatory sperm whale, ruined its corner of the seas with pretty similar behaviors. Unlike modern sperm whales, which mainly hunt squid, Leviathan seems to have specialized in large prey, like other whales, dolphins, seals, and giant fish.
What makes this period so interesting is that these predators may have been competing for the same prey, large whales. And that means the Miocene oceans were rich enough to support several gigantic hunters at the same time, which is hard to imagine today. Picture this. You're an orca, minding your own business, trying to hunt a dolphin, and then you see a Leviathan. Turn around and you see the Meg. It was a dangerous time period.
The Miocene oceans were incredibly biologically rich, supporting huge populations of marine mammals. But once again, climate change is cutthroat. And as the world shifted to a cooler, more seasonal world, ice spread at the poles and once stable oceans grew more unpredictable. Eventually, both Leviathan and Megalodon disappeared.
After Megalodon and Leviathan disappeared, whales got bigger. The largest ones became filter feeders, but some whales continue to rule the seas to this day. Our current heavyweight champions are the toothed whales, and among them, sperm whales and orcas reign supreme.
Orcas set the standard for smarts and speed. They target fish, seals, sharks, and even whales. They hunt in coordinated family groups and communicate techniques culturally. Different populations of the same species have developed entirely different hunting strategies. Some create waves to wash seals off ice, and others specialize in shark liver extraction.
Orcas are unusual because for a lot of Earth's history, apex predators became dominant by growing larger and stronger. Orcas took a different path by weaponizing intelligence and learned behavior.
But sperm whales are the largest of the largest ocean rulers of today, reaching up to 20 meters long. But even they don't need to rely on the brute strength of predators of the past. They specialize in deep-sea technology. Using powerful echolocation, they can dive thousands of meters into complete darkness in search of giant squid, exploiting one of the largest and least explored habitats on Earth.
If one thing's consistent about the ocean, it's that it's always had dynasties, from alien-looking invertebrates to armored fish, to toothy reptiles, to finally the mammal age of intelligence, cooperation, and efficiency. For 500 million years, something has always been waiting at the top of the food chain. But mighty as they can be, they don't last forever. And the way older champions have gone is a reminder to take better care of our planet.
The ocean is deep, dark, cold, and full of mysteries. The bottom is so poorly understood that we know the surface of Mars better than the depths of our oceans. But what we do know is that down there, things get big. Some might even say giant. Shrimp-like crustaceans longer than your forearm. Isopods the size of cats. Crabs the size of cars. And squid so massive they could square off with a school bus. But why? What is the reason behind these species growing so much longer than their shallow water cousins? This is deep-sea gigantism. Why does living in the deep make everything so weirdly gigantic? Is it something in the water? Or is it something missing from the bottom of the ocean? Let's take a deep dive into what's really going on down there and why life in the deep tends to go big or go home. The ocean is weird all over. But the real mythological creature-like stuff starts happening at around 1,000 meters, or 3,200 feet. That's like 3 Empire State Buildings stacked one on top of the other, but imagine they were all covered in water. This is the Midnight Zone. The sun doesn't shine here. It's an unforgiving place, and yet over 3/4 of the ocean are over 1,000 meters deep. So there is more area of deep ocean than there is land on Earth. This place is dark, cold, and home to one of the ocean's most mysterious and oldest giants. the Greenland shark.
These massive sharks get up to 6.5 meters, or about as long as an American pickup truck. They're the third largest sharks in the world, but the largest active predators, because the whale shark and basking shark are plankton eaters. As you can probably tell by their name, these massive fish live in the cold waters of the North Atlantic and Arctic Oceans. Unlike their movie star great white cousins, these guys are not flashy. They move at less than 2 kilometers per hour, the slowest known swim speed and tail beat frequency of any large fish. But this isn't laziness. It's crucial to their survival, even though they can sneak up on seals and have been found with polar bear remains in their stomach. Food doesn't come easy or often. They can go without food for several weeks, potentially even months, depending on the size of their last meal. But moving slowly helps conserve energy in a place where calories are rare.
To survive in a place with no sunlight and little food, you have to be very energetically efficient. One of the key factors is metabolic scaling, the idea that as animals get larger, they use energy more efficiently. So even though the Greenland shark is massive, it needs surprisingly little energy to live. But on the flip side, it also has very little to use. So they're extremely slow and grow less than a centimeter a year, sometimes over centuries.
Radiocarbon dating has shown the existence of 400-year-old Greenland sharks, making them the longest living vertebrates in the world. There are Greenland sharks that are alive today that were already swimming around England when Shakespeare was still alive.
Their slow growth also means it takes a long time to become sexually mature. In the Greenland shark's case, it's around 150 years of age. A Greenland shark could have been born the same day as Winston Churchill, and is only becoming sexually mature today.
But that kind of slow, steady growth over a very long lifespan isn't unique to the Greenland shark.
And maybe even weirder, it doesn't stop. Myself and you, unless you're a deep-sea giant, of course, grow to a certain height and then stop growing. But a lot of deep-sea species don't have that hard limit. As long as they're getting food and not getting eaten, they'll just keep growing. And when you combine that with the fact that these animals often live for a very long time, you get some really strange, humongous beasts with long lives and even longer legs.
Really long legs. The Japanese spider crab holds the title for largest arthropod on Earth, with a leg span that can stretch up to 4 meters across, or about as big as a sedan. And yet, its body is surprisingly modest, not much bigger than a football. These towering crabs haunt the deep waters off the coast of Japan. And despite their terrifying size, they're not predators. Instead, they prefer the chill lifestyle of a scavenger, eating whatever happens to fall to the bottom of the ocean. Aw, slender crab's kinda nice.
Predation requires a lot of energy, and few animals in the deep sea can afford to pay that price. This has caused low predation pressure, which has led to gigantism. When nothing's chasing you and you've got centuries to kill, there's room to grow big, slow, and strange.
The spider crab isn't the only deep-sea creature taking advantage of all that space and safety. Meet another bottom dweller built for the long haul, the giant isopod. It's a relative of the common roly-poly pillbug, but these armored crustaceans can grow to the size of a French bulldog. They live from around 200 to 2,000 meters below the surface, where they vacuum clean the bottom of the ocean. Almost anything is edible to them. Whale fall, fish carcasses, even scraps from shipwrecks. It's all delicious to them.
Like other deep-sea giants, their bulk likely evolved in response to cold temperatures, limited food, and a low predator environment. The kind of setting where getting big and staying still actually pays off.
They're so good at conserving energy, one captive isopod famously went over 5 years without eating, the longest recorded fast by any animal in captivity. It's the deep-sea version of bulking season. Store energy, move slowly, and wait out the next meal, even if it takes months or years to arrive.
So far, we've looked at animals that got big by taking it slow, conserving energy, playing the long game, and having no predators. But not every deep-sea giant is built for a quiet life in the dark. Some got massive in part because of an evolutionary arms race with a predator.
Enter the giant squid, with tentacles as long as a school bus and eyes the size of dinner plates. The giant squid is a real contender as one of the most terrifying ocean creatures of all time. Most common squid species max out at just a few dozen centimeters, barely the length of your forearm, making this giant squid one of the most extreme examples of deep-sea gigantism ever recorded. Its massive size is likely the result of its battles with the largest toothed predator on Earth, the sperm whale. What, did you think I was going to say T-Rex? Gotcha. While no one's ever filmed a full-on squid whale showdown, the evidence is etched on the whales themselves, in the form of sucker scars on their heads and squid beaks in the whale stomachs. Over time, natural selection likely favored squid that were large enough to escape, strong enough to fight back, or at the very least, harder to swallow.
This is an example of size evolving in response to predation pressure, when the pressure to avoid being eaten leads to an increase in body size. Combine that with the other forces we've seen, cold temperatures, slow metabolisms, low light environments, and you have a creature that's grown massive by design. The deep sea conditions simply demanded it.
There's another often overlooked factor that creates giants: oxygen availability. In some parts of the deep sea, oxygen levels drop dramatically. Oxygen minimum zones, usually found between 200 and 1,000 meters deep, are regions of the ocean with so little oxygen that most marine life cannot survive there. These midwater zones can have even less oxygen than deeper parts of the ocean.
But the real fun stuff starts to happen after 1,000 meters deep. This is an area with little life, little death, and little decay. Fewer rotten things means more oxygen, and deep ocean currents bring additional oxygen to the depths of the sea. Animals that can live here naturally get bigger than animals that have lower oxygen available.
Such is the case of the supergiant amphipod. Let's back it up a bit. If you've never heard of amphipods, all you need to know is that they're crustaceans that look like flat shrimp. Most amphipods are the size of your fingernail, but the supergiant amphi can grow up to 35 centimeters long, about the size of a house cat. These ghostly crustaceans can live at depths of over 6,000 meters. Their gill structure helps them extract oxygen more efficiently than their shallow water cousins. That extra oxygen intake powers a bigger body. A body that's perfectly suited for drifting through the pressure-packed dark, scavenging whatever it can. It's a reminder that in the deep, even the tiniest creatures can take a giant leap if evolution hands them the right tools.
These are just some of the most well-known deep-sea giants. There are several other giants that we're just beginning to understand.
Dumbo octopus are beautiful, hilarious, and look like cartoony octopus ghosts. But they're also larger than the average human being. Their adorable ear-like fins help them hover around while spending almost no energy. Giant polychaete worms, like the bobbit worm, can get to nearly 3 meters long and get energy from symbiotic bacteria. And siphonophores, though technically not an individual animal but colonies of animals, can be up to 40 meters long. These ones for sure deserve their own episode, so we'll talk about them at length another time.
At the bottom of the ocean, life slows down and stretches out. And somehow, against crushing pressure, freezing temperatures, and total darkness, life, finds a way.
Understanding these animals can help us understand life as a whole. For example, Studying giant amphipods has led to the discovery of unique molecules that protect cells under extreme pressure and stress. And these molecules may one day help prevent the protein clumps seen in diseases like Alzheimer's.
And the best part is that we've barely scratched the surface. More than 80% of the deep ocean remains unexplored, which means there might be other huge alien-like creatures down there just waiting to be discovered. And Godzilla. In Greek mythology, the Chimaera was a fire-breathing hybrid of a lion, a goat, and a snake. This fantastical, mythical creature has inspired the name of one of the spookiest species in the deep. And it makes sense. This deep-sea relative of the shark looks like it's been stitched together from pieces of other animals. Behold, the Chimaera. Chimeras, also known as ghost sharks, are the forgotten members of the cartilaginous fish class Chondrichthyes. When people talk about these fish, they usually only talk about sharks, rays, and skates. And forgotten are these deep-sea Frankensteins. The majority of Chimaera live in the deep oceans around the world, thriving in depths beyond 200 meters. Some Chimaera have been found living at 2,600 meters deep, though there are a few species, like the fantastically named Chimaera monstrosa, that live in much shallower waters, around 50 meters deep. The Chimaera's closest relatives are sharks, but they parted ways 400 million years ago, about 10 million years before our ancestors emerged from the water. And they haven't changed all that much since. Chimaera are the most primitive known cartilaginous fish. While they still bear some resemblance to sharks, they can be easily told apart. One of their most prominent differences are their gills. Sharks can have up to 7 gill slits, while Chimaera only have 1. And their gill slit is covered by a flap called an operculum, like bony fish. Also like sharks, Chimaera don't have any bones in their body, and their skeleton is made of cartilage. Depending on the species, Chimaera can measure up to 1.5 meters long. While they are hard to study due to their deep-sea locale, they're estimated to live well over 20 years in the wild. To defend themselves, most Chimaera come equipped with a venomous dorsal spine. This spine is located on their backs. It's a modified scale and it breaks off after every use, after which the Chimaera grows a replacement. This dorsal spine is very useful in defense and is incredibly painful to humans. Chimaera venom can cause necrosis, hallucinations, localized paralysis, and a lot more. You do not want to mess with these ghosts. Chimaera reach sexual maturity fairly late in life, and like sharks, male chimeras have external reproductive organs called claspers. They use these tubes to insert sperm into the body of the female. If successful, the female will lay large, leathery eggs. Chimaera have a particularly difficult time when targeted by fisheries or when caught as bycatch. Their bodies are so adapted to living at crushing depths that when they're hauled out, their bodies can't handle the change, and most don't survive the process. There are 3 families of Chimaera. The first contains the plow-nosed Chimaera, or elephant fish. They get their name from the fleshy appendage sticking out of their face. They can measure up to 125 centimeters long and use their plow to find bottom-dwelling prey, like sea urchins, mollusks, and crabs. Their plow is lined with electroreceptors, which help locate hidden prey by sensing their electric field. Every time a muscle moves, it creates an electric field. Even if their prey sits perfectly still, their hearts give them away. Then the Chimaera strikes, crushing their prey with their broad, flat teeth. While elephant fish may have the most specialized electroreceptors, all species of Chimaera have sensory organs used to detect electric fields to find prey. And the coolest thing? You can see them.
If you look closely at this chimera's face, you'll see that it's lined with little dots. These are their electrosensory organs. Similar to frogfish, elephantfish have large pectoral fins that help them move along the ocean floor.
The second family are the short-nosed chimera, or ratfish.
Their snout is much shorter than their plow-nosed cousins, and they have a much longer and skinnier tail, hence their name.
Finally, the long-nosed chimera.
These fish have long, paddle-shaped noses, and all 8 living species are found in deep, open water.
They're also known as spookfish, for obvious reasons. Also definitely reminds me of Zero from Nightmare Before Christmas. Anyone else getting that vibe? When you hear the name Stargazers, you probably imagine a cute, romantic, wistful-looking fish. But you'd be dead wrong. Meet the Stargazer, the electric, venomous, monster of the sea, and new addition to my nightmares. Stargazers are fish of 2 families, electric stargazers and sand stargazers. We are going to be talking about electric stargazers. Stargazers look like 2 different creatures. One, a bit of an oddly shaped fish when they're swimming around, and the other, a vaguely human monster hybrid face when they're buried in the sand. It's this second form that they get their romantic name from. Stargazers are ambush hunters, adept at burying themselves in sand and waiting for prey to swim by. When it does, they shoot out from hiding, creating a vacuum with their oral cavity that sucks prey into their oversized mouths. Their bites are breathtakingly fast, capturing their prey within 150 milliseconds. There are over 20 different species of stargazers, ranging in size from 15 centimeters to just under a meter long. And they can be found all over the world in relatively shallow water, usually between 5 and 150 meters deep. Being ambush hunters, stargazers are not picky eaters, but usually find themselves eating unsuspecting small fish, crustaceans, and cephalopods. In order to dig themselves into the ocean floor, they have large shovel-like fins, perfect for burrowing in and waiting for prey. In case you were thinking these amazing little monsters weren't frightening enough, they're both venomous and electric, so that's fun. Their venom is located in 2 sharp, long, bony spines on their back that can fold down. Stargazers primarily use their venom to deter predators and to kill prey. Humans get stung by them fairly often, but the venom isn't usually lethal, though there have been several reported fatalities from the Mediterranean species Uranuscopus scaber. Stargazer venom is a bit of a mystery. Scientists haven't been able to determine what the venom is or even how it works. When they have tried to remove the venom from their glands, they were unable to confirm any toxicity in the substance. Scientists believe this is because their venom is highly unstable. As I mentioned before, stargazers are not only venomous but capable of producing electric shocks. Many species of stargazer come equipped with electroplaxies, which are these stacks of polarized, flattened muscle cells that function somewhat like a capacitor. They're capable of producing a 50-volt shock, potentially enough to scare off predators, but not quite enough to stun prey, as some researchers have previously thought, though its specific function is still unknown. This electric organ, which is located behind their eyes, when triggered, creates a current that flows through the body of the fish.
He's kind of biting. Boy, that's like a stargazer. Something really poisonous.
You just threw it on the baby.
I didn't know the baby was there. I think I touched the spike at some point.
This whole process is incredibly fast and is over in milliseconds. In order to make another zap, they'll need to charge their batteries by snacking on prey. While they usually create short bursts of electric energy, occasionally during spawning, stargazers will create a longer burst of electricity, lasting several seconds, in order to help them find mates. Some species of stargazers come equipped with lures to help them snag prey. These resemble worms that are attached to a fishing rod-like appendage on their lower lip. If you look closely at their mouths, you'll see that they kinda look like zippers. In fact, the mouth of the stargazer is interlocked with tiny bristles which prevent sand from falling into their mouths when they're buried. A system that works about as well as it can, but still lets some sand in when they open their mouths to grab dinner. But stargazers have a second lore as well. This one is their specialized gills. They will discharge seawater next to their pectoral fin, which causes the sand to swirl around a bit as if there was a very small fish present. When a larger fish comes to check it out, the stargazer opens up its mouth and snaps it up. They will also use their eyes to lure in prey. Once a small fish is almost in range, the stargazer will rotate one of their contralateral eyes in order to give the impression that a small burrowing creature is there. This will draw in a curious fish before, As if these little monsters didn't have enough going for them, some species, like the Black Sea stargazer or Urenoscopus scaber, comes equipped with the ability to create acoustic pulses. They can emit a low-frequency acoustic discharge between 5 and 10 hertz, just below the human hearing threshold, which researchers believe they use to stun prey and attract mates. Funny how those two abilities often coincide, isn't it? What do you want me to talk about next? Please let me know in the comments and be sure to subscribe for new episodes of Animalogic every other week. Thanks for watching!
What is the last thing you'd expect to trip over in one of the driest places on Earth? How about the bones of possibly the largest whale to ever exist? Early estimates put it at close to 20 meters long and weighing 340 tons. And when I say big, I mean textbook example of gigantism kind of whale bone. That's exactly what happened to researchers in the Ica Desert back in 2013.